All right, tonight we're just going to review what we did in class, do a couple more examples to make sure we fully understand factoring polynomials. So, when factoring, first thing we always have to do is look for a GCF. So you're always going to look for a GCF, because if you can factor out a GCF, you need to do that right away because it's going to be a factor, it's going to be part of your answer. So keep in mind what I mean by GCF is if I have something like 2x squared minus 8x minus 24, I'm looking to see if there's a factor that's the same in every single one of these terms. And there is, in fact. We can take out a 2. We can factor out a 2. So we do that first. We write our GCF down at the bottom. So there's our GCF, came from there. And we're left with x squared minus 4x minus 12. Once we've looked for a GCF, and if we have one, we've taken the GCF out, we've factored it out and rewritten it, the next thing we're going to do is we're going to either use our app, and I'll take you through that again, how to do that, or use the rules of factoring. So remember numbers that multiply to the third number. And add to the second number to factor completely. So what does this look like? Well, if we're starting here, we're at this point, we know our answer has to have 2, it's got to have that GCF, and now we're factoring this last part, x squared minus 4x minus 12. So we can do that in our app by going in our calculator. We first go to apps, so you click that apps button. Okay, then we go to Polysmelt 2. So it might not be the same number. In my calculator it says the number 4, but yours might be different. So I'm not going to tell you specifically what number, but it's going to say Polysmelt or Polynomial Simultaneous 2. So wherever that is, you select that. And then you might have to hit enter again just to get into the app. Okay, and then we go to the first one, Polyroot Finder. Polyroot Finder. Now the roots, these are the same things as factors that we're finding. We'll get more into that later when we look at quadratic equations. Okay, we're going to make sure that our order, if we're looking at a degree that is x squared, something like that, the order comes from the highest exponent. So our order should be 2. It should be real numbers. Okay, we want to make sure that it's in fraction mode, not decimal. So you definitely don't want it to be in decimal. You want normal, float, and degree. Okay. Now these won't reset every single time you use the app, but it's always good to make sure that they're set up that way, because if for any reason your calculator is reset, like before the SOL test, these things might default to different options, all right? So make sure they're highlighted, and then we go next. And now we're ready to type in our coefficients. So your screen is going to look like a2x squared plus a1x plus a0 equals 0. Okay, so remember, this just means the coefficient in front of x squared, the coefficient in front of x, and then the final constant, the last number. So let's take our example that we're looking at. If our work was for, we originally had 2, and then it became x squared minus 4x minus 12. Okay, so our a2, or our first number, is going to be 1. Our a1, or our second number, will be negative 4. And then our final number is going to be negative 12. So we can enter those into our calculator. 1, negative 4, and negative 12. Then we select solve. When we solve, we get something like this. x1 equals 6. And x2 equals negative 2. That means that the solutions are 6 and negative 2, but we have to write them as factors. Okay, so far we have a GCF of 2, and we're trying to fill in these factors. Well, we use these numbers to complete the factors. We just switch the sign. So instead of saying x plus 6, we're going to make it x minus 6. Instead of saying x minus 2, we're going to make it x plus 2. And that is completely factored. That's a polynomial factored completely. And if you wanted to, you could use the box or the FOIL method to multiply these two things and then multiply everything by 2, and you should get our original polynomial of 2x squared minus 8x minus 24. So just a quick little review. When we're factoring, we always first want to look for the GCF and then factor it out if we can. And then we're either going to use the app or our factoring rule to factor completely. So let's see some examples to try that. So how about this example? We have x squared plus 11x plus 30. So we can certainly plug this into our app, or if you want to think about the rule, we're looking for numbers that multiply to 30. So they multiply to 30, or they add to 11. Well, they also add to 11, okay? So numbers of 30 that are numbers that multiply to 30 or add to 11. If you'd rather use your calculator app, we can go through that as well. So you go to your apps, Polysmelt 2, Polynomial Root Finder, order, make sure all that's good. Okay, and let's enter in our A1, our A2, and our A0. A2 is the coefficient in front of x squared, which is 1. The next number would be this coefficient, 11. Last one is going to be the number 30, positive. Okay, let's solve it. We find that x is equal to -6 and -5. So we'll write those as factors, x plus 6, x plus 5. And if you did it this way without the app, 5 and 6 are numbers that multiply to 30 and add to 11. So that's why it works. Okay, how about another one? Let's try this one. So let's do k squared plus 17k plus 66. Okay, k squared plus 17k plus 66. Numbers that multiply to 66 and add to 17. Or you can use your app. We should find that we get k equals -6 and -11. So our factors will be the opposite, k plus 6 times k plus 11. Okay. Now this example and the previous example were kind of nice because there wasn't anything that we needed to factor out of it. So let's see one where we're probably going to have to factor. So it might look like this. Let's say we have 3y squared plus 24y plus 48. So what can we factor out of everything? Well, we can factor out of 3. So 3, 3, and 3. So we're going to be left with 3 times y squared plus 8y plus 16. Now, if you're using the app and the calculator, remember we found that you could actually use the original polynomial, plug that into the app, and you would be able to get the right factors. Just make sure that when you're doing that, you still have to include the GCF3 in your final answer. So our final answer is going to be a factor of 3, the GCF, and then 2 quantities. When we do this, we're going to find that it's actually going to be the same number. So you'll find that y equals -4, y equals -4. So that just looks like y plus 4 times y plus 4. And notice how y plus 4 and y plus 4 are the same thing, like this. So when we see that, we can actually just write it like this. We can write it a little bit more simply. We can instead write it as y plus 4 squared, and we'll just get rid of this guy. Y plus 4 times y plus 4 is the same thing as y plus 4 squared. So that is our final answer. All right, how about this example? So let's see if there's anything we can factor out of every single term. I've got 2x squared plus 5x plus 3. There's actually nothing we can factor out, so we can go to our app and enter those numbers, and let's see what we get. So we're going to put in 2 for the first coefficient, 5 for the next one, and 3 for the final one. Let's solve. All right, so this is what my calculator tells me is my answer. X equals -3/2 and x equals -1. So if we write these out as factors, x, remember we switched the sign, x plus 3/2 and x plus 1. This looks all right, but I cannot have a fraction here, okay? So remember our trick of getting rid of that fraction. If I have a fraction, I take the denominator 2 and I put it in front of the first term. So instead of it being x, it's now going to become 2x plus 3. And then x plus 1 can just stay the same. One thing to remember, we mentioned this in class, but I'm sure some of us didn't hear it, it doesn't matter the order in which you write the factors, okay? So this answer is perfectly fine. It's also perfectly fine to write your answer like this, x plus 1 times 2x plus 3, based on the commutative property of multiplication, okay? So either one of these answers is perfectly acceptable. All right, how about this example? So I've got 5x squared minus 17m plus 6. So first we got to check, is there anything that we can factor out of every term? No. All right, I'm going to go to the app. 5 is my first coefficient. -17 is my next coefficient. And finally, 6 is my last number. And I just realized I used an x and an m, so let's just make this mx, okay? Sorry about that. All right, so we've got 5, -17, and 6. Let's solve, see what we get. All right, they tell us that x is equal to 3 and x is equal to 2/5. So how would this look? I've got x minus, not 5, I've got x minus 3 and x minus 2/5, but we can't have a fraction in our answer. So we're going to take the denominator 5, put it in front of x. So now we've got 5x minus 2 times x minus 3 for our final answer. Think back to our notes today where we talked about factoring by the difference of squares. Okay, so this would be something where we have perfect squares like x squared subtracted by another perfect square like 25. So the rule for this, we can certainly put this in our calculator, or we can write it this way. It's going to be 2 factors, and it comes from the square root of each part. So think about the square root of x squared is just x, so x will be the first term. Then we have the square root of 25, which is 5, so that'll be the last term. And then 1 is always positive, 1 is always negative. Okay, so that's our rule for difference of squares. Now, you can do this in the app perfectly fine. However, there's going to be some times where it's more variables that you can't actually plug into the app. So here's an example of that. I have 4h squared minus 25g squared. Okay? So the important thing to notice here is that there's 2 different variables, but we can still follow the same rule. Okay? Notice I've got a perfect square subtracting another perfect square. That's important because if these weren't perfect squares, or if we weren't subtracting, then this whole difference of squares method wouldn't work. Okay, so we got to just make sure that it does work. Or we have to make sure that that's true so that we can use it. So let's set up our factors. I've got this, one on the left, one on the right. Let's take the square root of the first part. I have 4h squared. Well, the square root of 4 is 2, and the square root of h squared is just h. All right, in the next part, we're looking at the square root of 25g squared. The square root of 25 is 5, and the square root of g squared is g. So we've got 5g here. Finally, make one positive or one plus, make one minus. And that would be our factored version of that polynomial. Okay, let's try another example of that. How about 64u squared minus v squared? So let's check. Is 64u squared a perfect square? Yes. How about v squared? Yes. Are they being subtracted? Yes. So we can use the difference of squares method. All right, so we're going to have 2 factors here and here. Let's take our square roots. How about the square root of 64u squared? That'll be 8u, 8u. Then the square root of e squared is just v. Make 1 plus, make 1 minus. How about this example? So what if I have 84, I'm sorry, not 84, let's do 81. How about I have 81x squared plus 36? Okay, so let's do difference of squares. Let's check. I got square root here, yes. Square root here, yes. Can we use difference of squares though? No, because we're adding, so it's not going to work for this. So we can't actually factor this. There's no real roots for this one, okay? So we'd say either no real roots or we would say it's prime, meaning it cannot be factored, okay? Awesome. All right, so make sure you complete the questions that are posted and submit your Google form.